Attention up here, please. Shh. Let me explain to you what we are doing today. On Monday, you were supposed to complete test corrections on this test if you needed them, right? And from what I understand, some people still had issues because you weren't sure if you were right or you didn't know how to correct them. Then there's additional things to that. Some of you may not have corrected at all because your grade was decent. Some of you may have corrected them and then thought they were all right, but maybe they weren't. And then additionally, maybe some of the ones you had on your test were right. Maybe it was because you guessed right? Do we ever guess right? And we're like, well, that's good, all right? And then you don't, so you don't really know if you got it right because you understood or because you guessed. So here's what we're going to do. Because I've been trying to think of ways, and I know your grades still have not changed. Trying to think of ways to make things fair, but still hold you accountable for what you need to do and what you need to learn. And the end goal of all of this is not to get a grade in the grade book. Get a fair grade in the grade, I want that. But it's for you to learn. Like you have a final exam coming up, like a for real final, and you need to make sure you actually understand this material. Even if you made a decent grade on the test, doesn't necessarily mean you understand it. So I'm going to work through the entire test with you. We're going to talk about not just here's how to find this answer, but some other things about these questions, what's wrong with some of these questions. Those are things you need to be able to pick out also, which you may have already noticed. And if you do everything with me, you are 100% engaged, and you write everything down that I do, and you ask questions, and all of a sudden, and you turn them back into me, I will give you half points on your test, no matter what your grade was. You made a 90, you get a 95. Does that make sense to you? Does that sound fair? What I want is for you to learn, right? I want you to learn and make sure that you understand it. I also want to make sure that you understand the other stuff that you're going over right now, special right triangles. Those are really important. I have something I can pull out and show you right now. Actually, I do. And I know those of you watching the video, you're not going to be able to see this, but we did this in pre-cal the other day. On the front, I know you can't really see from there anyway, but these are all special right triangles. All these little triangles that we cut out and put on this circle to learn trig stuff, that's way more than the trig stuff y'all are going to learn, all special right triangles. They're not going away. You're not going to use them at all in Algebra 2. Pretty much nothing you do in geometry you use in Algebra 2 at all. But in pre-cal, it all comes back, so it's still important. So if you have questions on these things, it's fine to have questions. You have to be able to be brave enough to ask them. But you can come to me for tutorials. Before school is a nightmare right now. I wouldn't even try to catch me before school, even though I'm here. Math time and priority day is tomorrow. I don't even have priority day anymore, okay? You can come to me tomorrow, even though it says priority. I don't even know that mine says priority, whatever. Doesn't matter. You can just sign up, you can just come, all right? For any other math times next week, same thing, all right? And after school. I can't ever complete anything, so I'm here forever. I rarely leave before 6, so I'd rather not show up at 5:30. But if you have something after school, I'm here. Come ask questions. Let's make sure we get this understood, okay? We all good? Question. Tutorials doesn't mean hours. Tutorials sometimes like 10 seconds. The question answered, and now it all makes sense. That's fine, right? And yeah, so let's get through this stuff because there's no special triangles or anything on here, and then we'll move forward from there, okay? We also have a plan for next semester that I think is going to work out very well for y'all. I think that you're going to be very excited about it, and I know that this has been a stressful situation. I do not want to see any of you jump ship out of pre-AP because this last month or so has been stressful and you're worried about grades and you haven't gotten a lot of help, all those sorts of things, okay? I want you to feel comfortable. Now, if you feel like you really need to get out, I would really rather, instead of you just going straight to the counselor or Mr. Ramirez, also I have asked for Mr. Ramirez to kind of direct everybody to me. Come have a conversation with me, and I can talk to you about you, and I can look up what happened in Algebra 1, those sorts of things, and try and guide you to the best path for yourself. But right now, I really don't want you, if you had been thinking about getting out all semester, that's different. But if you're thinking about getting it out because of this last 6 weeks, don't let that be the reason, okay? Does that make sense to you? I've been doing this, I've been teaching pre-AP geometry longer than y'all been alive, so I know how to have those conversations with y'all. I know how to, I know how to get you to the right place and make sure that we're all comfortable in what we're doing. All right, so let's look at number 1. So it says, we're given that line segment WY is the angle bisector of XWZ. So what you should always do with your given information is go in there and label it. So we've got line segment WY, which means that these two angles are congruent. We agree with that? Okay, then it goes on to say that the measure of angle XYW equals the measure of angle ZYW. All right, so do these two angles look like angles? Yes. And in the end, they are right angles. However, does that given information say that they are right angles? No. So We can't assume anything. You're taught to assume stuff all the way up until 8th grade, which is terrible. There's some terrible, terrible material to go on down there. And I had a long conversation with the pre-AP geometry at early college yesterday, mainly over this test and some other things that some of the resources for geometry, they're just junk. They're not written by people that understand geometry. They're written by people that, I don't know, sometimes I think they never took a geometry class. But we don't have the angles at this point. So all we can do is mark that they're congruent. That's all that the statement gave us, okay? And then we can decide what else we can label based on what we know at this point that's not assuming anything and not guessing, right? So the other thing we know, tell me something I can label. Anybody? What you got? Okay, good. So line segment WY is congruent to itself because of the reflexive property. We all agree with that? So now, based on what I have labeled, is that enough information to prove that the triangles are congruent? Yes, it is. All right, so the what else could I label at this point? Anybody give me anything else? We're not going to use it. It is not in here, but what else do we know based on what we have so far? What you got? Okay, and it's angle bisector because right. So how do you know it splits down the middle? It's okay. That's, we need to have these conversations. Because she said it. How do you know it splits down the middle? Of the segment? Okay. And then you know that because... Okay, if we're splitting an angle in half, then all we can say is the angles are congruent, okay? Now, is it true that... Yes, that is true. But at this point, we can't say that. If we could say that, if we had perpendicular segments to here, then I could talk about them being equidistant. That's one of those perpendicular things that we have. But at this point, although that stuff is true, we don't have enough information to say it yet. You with me on that? So once we prove the triangles are congruent, which we can do, then we can say those other things. Does that make sense to you? And that's what makes proof hard. No, it's true, but how do you know? You have to pretend like you're on the witness stand and I'm badgering you as a witness. How do you know? How do you know that? If you can't give me a postulate, a theorem, a definition, or property, then you can't go any farther with that at this point. Does that make sense to you? Okay, but that's good because again, you're right, but we can't use the key. What about angles x and z? Oh, sorry. Okay, why? Third angle theorem. Okay, so that's something right now we could say angle x congruent to angle z by the third angle theorem. Do y'all agree with that? Now, if I did that, then that's not where this is taking me. So I don't want to confuse you by putting too much other stuff in there. But if I did that, then I could still use angle side angle, but I could also use angle angle side, right? It's an extra that I don't need, but it's not wrong at that point. Okay. But you got to be able to have your why for your reason. So before we even look at what the question is, and it just asks us about step 3, we're going to talk about all of the steps. And I just realized I don't really have a lot. I wrote all mine down at the bottom, but then I scroll. I'll do them up here. So reason 1. WY is the angle bisector of angle XWZ. What's my reason for that? Given. Okay. 2. The measure of angle XWY equals the measure of angle ZWY. Why'd you say that? Why'd you say that? Because it's not the same angle. Are these the same angles as this? No. When you glance at them, they use the same letters mixed around, and so it can be confusing. That's these angles here. That's not the angles that they gave me. These are the angles they gave me. So how do I know these are congruent? It's an angle bisector. Now we get to use it. So this is our reason. What we write is important. We don't get to write it's an angle bisector. We don't get to write because it's an angle bisector. No, that's what you're thinking. If you're thinking that, well, it has to be because of what it is, like if that's the thought that's going through your mind, most of the time that means it's a definition because the definition tells you what it is. So this is just by the definition of an angle bisector. Okay, everybody okay with that? So then number 3, how do we know this? Reflexive property. Or how do we know this? Yeah, this one does match this. So this is given. And then 5 would be the 2 angle side angle. So it's angle side angle congruence. All right, so let's talk about angle side angle congruence. Okay, and you don't have your items out and stuff yet, but angle side angle congruence says something like if 2 angles of one triangle are congruent to 2 angles of another triangle, or the 2 angles in the included side of one triangle are congruent to 2 angles in the included side of another triangle, then the 2 triangles are congruent. Does that make sense? So the word that's used over and over and over again in there is congruent. If the sides are congruent, if the angles are congruent, then the triangles are congruent, blah, blah, blah. So this right here is a very bad question. In this proof, did we prove that 2 angles in the included side are congruent to 2 angles in an included side? We got any congruence in here? No, we proved that the measures are equal. Now, if the measures are equal, are they congruent? Yes, but equality and congruence are 2 different things. So one of 2 things should have happened here. Either this stuff should have been given to you as congruence, or once we put it in here as equality, then we would have to say that, like, if since wy is equal to the length of wy is equal to the length of wy, and that's fine, reflexive property. Then the next statement could be line segment wy is congruent to line segment wy, the definition of congruent segments. Like, you have to actually get it into congruence, because truly, we have enough information labeled and we know enough to do this, but in our proof, we really don't have enough to actually say this because we hadn't said anything was congruent. Does that make sense to you? So pieces, and so the answer is B here. And sometimes y'all don't necessarily notice those things if you haven't really focused on them. But the whole equality congruence thing and them being the same but different is truly important there. Okay? Any questions on number 1? All right, so let's look at number 2. Number 2 says, in this diagram, line segment AB is equal to AC. So those are marked. And it's fine to mark them congruent when you're told that, because that does mean that they're congruent. BAD is congruent to CAD. Those are marked congruent. And then we're proving that BD is, the length of BD is equal to the length of DC. So I'm not going to mark that they're congruent, because this is what I'm trying to prove here. Okay, so that's what I'm trying to prove. So basically, in order to prove that those 2 are congruent, I have to prove that the triangles are congruent, and then I can prove that using CPCTC, right? So again, do these look like right angles right here? Yes. Did they say anything about those angles at all? No. So at this point, I don't, unless I can, and I can say that because this point is equidistant from the 2 endpoints of this line segment, so it lives perpendicular. Could have kind of used that over there, but you have to actually say that stuff in the proof, okay? And so here, let's just walk through and put our reasons. The length of AD is equal to the length of AD, and our reason there is, good, reflexive property. And this is really the reflexive property of equality, because you also have the reflexive property of congruence, and there's also a reflexive property of similarities. We really should distinguish between them. Angle BAD is congruent to angle CAD. How do we know that? Given. The length of AB is the length of AC. How do we know that? Given. Then the 2 triangles are congruent by what? Oh, I didn't label this part. Okay, we put this in there. I didn't label that when we did that, sorry. So then I can prove that the 2 triangles are congruent. I have 2 sides in the included angle, and I heard it is side angle side. All right. So then, now that I've proven the 2 triangles are congruent, I can say that these 2 pieces are congruent by what? It's all those letters. CPCTC. CPCTC. Can anybody tell me what those letters mean? Good. Yeah, it's corresponding, but yeah, corresponding parts of congruent triangles are congruent. So basically, if after I say the 2 triangles are congruent, then all the other pieces we haven't talked about, they have to be congruent as well. So then the question says, which steps, if any, are in reverse order. Okay? So somebody tell me what they think the answer is and why.
1 and 3, because you usually need to put your givens first.
Okay. So I like the way that you said that too. He said 1 and 3, and then he said because you usually have to put your givens first. Now, is it fine to put your givens first? Do you have to put your givens first? No, you actually don't have to. Now, this is the correct answer according to the answer key. This is another reason I had some conversations yesterday. But there is no rule that says that the givens have to go first. And so then the argument was placed, well, the test generator said that that was the right answer. Well, great, test generators are wrong all the time. And let's say that whoever was writing all these said, you know what, givens have to go first all the time. They don't even agree with themselves, because is that what they did in number 1? No. So you're going to be really hard to win an argument with me if you can't even be consistent. All right. So although you could put you could switch these two, and would everything still be fine? Yes. If I switched 1 and 2, would everything still be fine? Yes. So those could happen, but they don't have to happen. Could I switch 4 and 5? No, 4 and 5 I could not switch. So order does matter, but one of the most difficult things about grading geometry is a lot of times there are an infinite amount of answers, or there are multiple answers. Or when you write a proof, you can put them in all kinds of different orders and we could all be right, and it's just kind of a nightmare to grade. And it's also when you work with each other, argue about whether or not you're right or wrong, then you get into some heated arguments and we have to go and break it up and say, it's okay, you're both right. Calm down. It's okay. We can both be right and be different. So truly, the correct answer is all steps are in, I should say, like in a correct order, because there's multiple correct orders. The only time you have to worry about where your givens are, like for instance, if you look back at this one, if I try and say that these two angles are congruent by the bisector, and I haven't said that I have an bisector yet, that makes no sense. So this given, but number 1 doesn't have to go before number 3, and it doesn't have to go before number 4. I could have done this over here, of course, I have to switch around. So I could have done 3, 4, 1, 2, 4, 3, 1, 2. Doesn't matter. Other given could have. There's lots of different orders, so you have to make sure that whatever you're saying makes sense, that you have backed up what you're doing. We all on that one? So could it be possible that you had the right answer and it was marked wrong? Could have been possible that you put B, which is not the right answer, and it wasn't marked wrong, but we're all going to get half points back. It'll leave it out in the end. So let's look at number 3. This is in this figure. Oh, geez, only 15 minutes. In the figure, the measure of angle CNA is equal to the measure of angle WN, and line segment and the length WA. What congruent statement proves that these angles are congruent? So here you can leave it like it is. You can separate and redraw them. It kind of depends on the picture and what's going on with it, whether or not you want to do all of that. So let's label and see what we have. We have CNA, which is this angle, is equal to the measure of angle WAN, which is that angle. And then CN is equal to WA. And then it says what congruent statement proves that these two triangles are congruent. Now, how many sets of congruent triangles are in this picture? There's 2 sets of congruent triangles. Do we agree with that? We've got this here and its respective partner over there, right? And then we also have this one and its partner, like little wings, right? And then we have this lonely guy that doesn't have a congruent one in there. That's why sometimes you want to separate and redraw them. Like I have congruent vertical angles here, but nobody cares. It has nothing to do with what we're doing. If we were doing these 2 triangles, that would be different. But based on what they've given me, since they gave me this big one, they're giving me that big pink one there. Does that make sense to you? So I'm trying to do these 2 big ones and prove that they are congruent. So what else between those 2 big ones can I draw, or can I label? The reflexive property, because here NA is congruent to itself. You see that? And so if I separate and redraw them, and they look something like this, well, a lot better than that, but it's fine. These 2, they gave me, and they gave me this. And because they overlapped it in A, that makes these 2 pieces congruent. There's my side angle side. Okay. Draw and label, draw and label. I cannot stress to you enough how important it is. Everybody good? Any questions? Let's look at number 4. It says the single side congruency axiom states that two triangles are congruent if. All right, axiom. What's another word for axiom? Anybody tell me? There's a lot of vocabulary in geometry, and if you don't know what the heck they're talking about, it makes it hard to figure anything out. So another word for axiom is a postulate. Who can tell me what a postulate is, like the general definition of what just a postulate is? Anybody? What the difference between a postulate and theorem is? Do we know? We don't know? Okay. So a postulate is just an accepted statement of fact. Okay, so it's kind of common sense. Not, well, common sense if you understand the material, but we can say that this has to be true. And you'll be like, yeah, that makes sense. That has to be true. But I can't prove it. I don't have enough information to prove it, or I don't have the theorems or whatever to prove it. It's just we all accept it. We move on. Nobody can prove that it doesn't work. A theorem we can prove. We can actually do a mathematical proof, because believe it or not, you can do mathematical proofs for every rule that you have, not just congruent triangles. But I can actually prove it using other theorems, postulates, definitions, whatever. So an axiom and a postulate, they're just accepted statements of fact, and we use them as, you know, actual rules or whatnot. Okay. So the SAS congruence postulate, right? Are you awake there? Yeah, so if you don't want your half points back, that's fine. You can take a little nap, we can get you a blanket, but I think you want your points. So the SAS congruence postulate states that two triangles are congruent if. All right, so let's just draw out two triangles. And, those don't look congruent, but here's the beauty of geometry. If I label that they're congruent, guess what? They're congruent. It doesn't matter that my pictures are terrible. So that's basically what your side situation would look like. We agree with that? All right, so there's of how many sides congruent to each other? Two sets of sides and one set of angles. And just like when it's written like this, the angle is included in the two sides. So as we read through this is two angles in the contained side. Well, that's not. Two sides in the contained angle. Okay, leave it. And then we get the angle again. All right, so I really only have to decide between B and D. So is the angle for side angle side included or not included? Included. So two sides in the contained angle or two sides in the excluded angle, it would be contained angle. One triangle are equal to two sides. So tell me what's wrong with these statements just all together. They say equal. Can sides be equal? No, sides absolutely cannot be equal. The lengths of the sides can be equal, but sides are congruent. If I have line segments like this, let me just draw this. And I can say that they're congruent. So I have AB and I have CD, right? So for you to tell me that these two segments are equal makes no sense. Pictures cannot be equal, all right? Just like numbers cannot be congruent. What we have here for these two is that line segment AB is congruent to line segment CD. Line segments are congruent. And then the length of AB is equal to the length of CD. This represents numbers. This represents figures or pictures, drawings, things. Okay? Things are congruent. Things, numbers and things that you can apply a numeric value to are equal. Okay? You cannot say segment equals 5 centimeters. No. The length of the segment equals 5 centimeters. Do you see the difference there? So they're the same, different. It's being little, it seems very nitpicky, but it is. Again, if you're on the witness stand, that lawyer is going to tear you apart on technicalities about things, the same kind of thing. All right, number 5. Which of these statements is most useful to prove that two triangles are congruent using the angle-side angle postulate? All right, so let's look at this picture. Tell me what's bad about the labels on this picture. Yeah, they both have just the one. Like if the numbers weren't there, all 4 of those angles would be labeled as if they're congruent to each other, right? And they clearly are not. But the numbers are there, so that at least helps us know that it's bad, I guess. And there. So that looks a little bit better. So we have the sum of the interior measures of a triangle is 180 degrees. That's a true statement, right? We can all agree with that. That would mean that's where we get the third angle theorem from. Is that going to help me using angle side angle? No, because I already got the angles I need for that, right? Every angle has exactly one bisector. Well, that's not even a true statement, not even for this picture, so that definitely doesn't make any sense. Angle B is congruent to angle D. Is this a true statement? Yeah, it's a true statement by the third angle theorem. Does it help me? No, so I certainly hope D does. Segment AC is congruent to segment AC. Is that true? Yes, by the reflexive property, so this is what's going to help us the most. Okay? Everybody good? All right, good deal. Let's go to number 6. So which diagrams show that the two triangles must be congruent? Must be. Not that they could be, but they must be. So those little words in there are important. If I said could be, totally changes the game here. So when I look at number 1, I have two sides in the angle. Right? These two sides congruent to these two sides, these angles congruent. Is that enough to say for sure these triangles are congruent? No, because that's not side angle side. It has to be this angle, right? This is side angle, or this is angle side. Ass in geometry. Whether you write it frontwards or backwards, it ain't happening. So number 1 is a big fat no, which means I can eliminate A and I can eliminate C. Right? Then I look at number 2. These two angles are congruent, these two angles are congruent, and this side's congruent. So now I have two angles and a side that's not included. Is that okay? Yeah, I can prove these two triangles are congruent by angle, side. So I like number 2, which means B is still in play and so is D. All right, so Roman numeral 3 here. These two sides are congruent, these two angles are congruent, this side's congruent to itself. So are those two can I say those two triangles have to be congruent? No, and it's not because, do they even look congruent? I don't think they do. But you can't go by the way it looks either. If I labeled this, then guess what? Those triangles are congruent. I don't care if you don't like my picture, right? But that's not what we have, so we'll erase that so it's not confusing. But so again, I have side angle. Side angle, or angle side, does work in some cases. What's the only time that actually works? Right triangles, and we don't even call it that. What do we call it for right triangles? HL, hypotenuse leg. So if I have this, right? These are congruent. Do we agree with that? Okay, they're congruent by HL. That's still side angle, but that right angle anchors that thing down, because otherwise there's more than one thing that could happen. It's called the ambiguous case. And I don't know if y'all saw what the options are. Did you see that and know why it's more than one thing? No? Okay. Yes, no, maybe. I feel like if I try and draw it real quick, my drawings are so bad it wouldn't work. But there's something I can show you real quick. I just don't have it pulled up. So that'll be for another day, I guess. But so we don't like number 3 either, which means D is no longer in play. My answer is B. Okay, everybody good so far? We learning anything? Oh, awesome. I like that. Makes it worth my while. All right, so number 7, they ended up throwing out. Number 7 is a very weird question. It's not necessarily a bad question, and the answer that was on there is correct. It's actually a really good question that makes you think pretty deeply. But we're just going to skip over that one for right now so I can get through things. Now, number 8. All of this is identical to number 1. It's the same proof, the same everything. It's being multiple choice, it's just asking you for a different of it. So statement 5, once we labeled all that stuff, we have that angle bisector. They told us these were congruent, and this is congruent to itself. Then we prove the triangles are congruent by what? What does that give me? Angle side angle, and it's B. Okay, we good? All right. Oh, good. Maybe I can actually, I think I can finish in 5 minutes. All right, so it says state the congruence relation for these two triangles. And so I have two sides of the non-included angle, two sides of the non-included angle. If any of you put B, shame on you. There is no ass in geometry. I don't care if you write frontwards or backwards. No. They're not necessarily congruent. Okay, we good? All right. So then it says, in the figure, the measure of angle T is equal to the measure of angle B. And E is the midpoint of line segment TV. And what congruent statement proves that the two triangles are congruent? All right, so this is all that they gave me. Since E is the midpoint of TV, does that mean it's the midpoint of RC? Not necessarily, okay? Because I could have this kind of thing going on, like that, where these two are congruent, but these are not, right? And so I don't necessarily know that. In the end, if the triangles are congruent, then yes, it is, but we haven't said they're congruent yet, so I can't just assume it's the midpoint. Does that make sense? So what do I know for sure at this point? Good. TER is congruent to CEV. Why? Vertical angles are congruent. Good. So if we can get that labeled, now I can prove that these two are congruent by what? Angle, side angle. Okay. Are we good? Any questions at all? Do you feel a little bit better about this material? Okay. So let me tell you what's going to happen in the next couple of days. Tomorrow you are going to have another sub for your sub. It's Miss Williams, though. She's been in there before. She's actually one of our student teachers. She's going to give you back some assignments that's really what I intended to happen like yesterday. She'll be giving you back some assignments. They're already graded for completion. Then y'all are basically going to grade your own for right or wrong. And you're going to mark them wrong if they're wrong. Nobody's changing your grade. You need to know if they're right or wrong. Does that make sense? So you're going to mark them if they're wrong, and you're going to work together, and she can help you. She's a math major. She's going to be a math teacher. So she can help you figure it out if you can't figure it out. But also figuring out amongst yourselves helps a lot. Okay, that'll be helpful to you. And then by Friday, I will give you your final exam review. I will make the videos for final exam, the review, so I will work out each question. I will explain each question probably more thoroughly than I usually do because I'm not sure what you know and what you don't. I didn't know you don't know what a postulate was, things like that. And then final exam reviews tend to be kind of long sometimes, so I want to make sure that it may not be all in one thing. But I highly suggest that you watch them. If you don't want to watch the whole thing because they're long and you get tired of it, just fast forward and double check the answers and make sure we agree. And just listen to the pieces that you're confused about or that we don't agree on or whatever. You don't have to necessarily watch the whole thing. But just sit down and just work it out as I'm working it out. You need to work through it first so you know what you can actually do on your own. Okay? Any questions at all? All right, good deal. So I need you to make sure your name is on this. Stack this up on your table. You can just leave it on top of the clear boxes. And I will come and get them in just a minute. And I think y'all still had a blue paper. Somebody was asking me. The green paper, do all of you still have that? Oh, okay. All right, you can just give it to me. If you have anything else to turn in, just hang on to it. But make sure you do not take this test with you or I can't go make those corrections. Oh, one more thing. There was something y'all did in Schoology, a quiz or something, and I unlocked it for one person. I think I unlocked it for everybody. I'm not sure. I think I did, but some of the classes aren't linked correctly. But everybody can go back and retake it again if you want. If it's not open for a second time, let me know. Okay? Are we all good? You don't need anything else? Okay. I promise you it'll be fair in the end, but you have to advocate for yourself. Okay? Ask questions if you've got them.